Chapter 4. Building the Evidence. Sherlock Holmes would be proud. Milton Humason never planned to become an astronomer. He came to Mount Wilson to work. High above Los Angeles, where the air was cool, the nights were dark, and the stars blazed with remarkable clarity, a new observatory was rising from the mountainside. It would soon house the largest telescope in the world. An instrument capable of reaching farther into the universe than anything humanity had ever built. But before it could explore the heavens, it first had to be built. That was where I entered the story. I drove mule teams up the steep mountain trails, hauling timber, steel, machinery, and supplies to the summit. Every beam, every bolt, every crate of equipment, everything the observatory needed had to make the climb. I helped build the roads. I helped build the buildings. I helped build the observatory itself. Astronomy wasn't my ambition. It was simply my job. When the construction was finished, I stayed. At first, I became the caretaker. I maintained the buildings, prepared the observatory for each night's work, made sure everything was ready before the astronomers arrived. I had little formal education. No university degree. Nothing about my early life suggested that I would one day help uncover one of the greatest discoveries in science. Yet every clear evening, the mountain transformed. As the sun slipped below the horizon, the observatory came alive. The great dome slowly turned toward the sky. The shutters opened, the telescope awakened. Every night, humanity reached a little farther into the unknown. At first, I simply watched. Then I began to help. I learned how to prepare delicate photographic plates in complete darkness. I learned how to balance the great telescope as it followed the stars across the sky. I learned that observing the distant universe demanded extraordinary precision. The galaxies we wished to study were unimaginably faint. Collecting enough light often required hours of continuous exposure. Sometimes, several nights. The telescope had to return to exactly the same point in the sky, again and again, collecting just a few more precious photons before a photograph revealed anything at all. It was painstaking work. A tiny guiding error, a mechanical vibration, a passing cloud. Any one of them could destroy an entire night's observations. Most people found the work exhausting. I found it fascinating. Night after night, I learned a little more. The telescope slowly became familiar. Its rhythms, its movements, its extraordinary precision. There were no shortcuts, only patience. Only practice, only another clear night beneath the stars. The astronomers noticed. Little by little, they trusted me with more responsibility. I was no longer simply preparing the observations. I was making them. I had arrived at Mount Wilson to help build the world's greatest observatory. Now, it was helping build me. Before long, I would help build something even greater. Not another telescope, not another observatory, but the evidence that would change humanity's understanding of the universe forever. The work itself was rarely dramatic. Most nights, nothing happened. Another galaxy, another long exposure, another fragile photographic plate, then another. The galaxies were so faint that only a handful of photons reached the telescope each second. Those tiny particles of light had left their galaxies millions of years earlier. They had crossed the immense darkness between the galaxies, only to arrive one by one on a mountaintop in California. Most people would have seen almost nothing. I saw evidence. Patiently, I collected it, one spectrum, then another, then another. Years earlier, Vesto Slipper had shown that the spectral lines of distant galaxies were shifted towards the red. They were moving away from us. It was a remarkable discovery. But remarkable discoveries are not the same as compelling evidence. Scientists are cautious. One observation may be an accident. A handful may be coincidence. Confidence grows only when nature keeps telling the same story. Again and again and again, that had become my task. Night after night, I pointed the telescope towards galaxies that lay almost beyond its reach. Some exposures lasted for hours. Others required several nights before enough light had accumulated. A tiny guiding error, a mechanical vibration, or a passing cloud could erase days of patient work. So I began again. Every successful observation added something priceless. Another measurement, another point, another clue. Individually, they revealed very little. Together, they were beginning to tell a story. As the years passed, the collection slowly grew. Edwin Hubble continued measuring the distances to the galaxies. I continued measuring their motions. Separately, our observations answered different questions. Together, they asked an entirely new one. One evening, we plotted the measurements. Distance on one axis, velocity on the other. At first, the graph looked almost random. One point, then another, then another. Slowly, a pattern began to emerge. The farther away a galaxy was, the faster it appeared to be moving away from us. It couldn't be a coincidence. The pattern was real, but its discovery raised even greater questions. Why were the galaxies moving away? Why did more distant galaxies move away faster? What force could produce such a pattern? Not every galaxy lay perfectly upon the line. Nature is rarely so tidy. Every observation carried uncertainty. Every measurement contained small errors. Some galaxies possessed motions of their own. Yet the pattern refused to disappear. Each new observation strengthened it. Each new galaxy whispered the same message. Distance and recession were connected. The universe was not behaving randomly. It was following a pattern. I had not uncovered that pattern alone. Like every great scientific discovery, it rested upon the work of many people. Henrietta Leavitt had given astronomers a ruler. Edwin Hubble had measured the distant galaxies. Vesto Slipher had shown that they were moving. I had helped gather the evidence until the pattern became impossible to ignore. Each discovery answered one question. Each revealed another. The observations had shown us what the universe was doing. They could not explain why. That answer would not come from another photographic plate. It would come from mathematics. How could mathematics explain something the world's greatest telescope couldn't? Georges Lemaitre would provide the answer.